Hello and welcome to our third week in bioethics and biotechnology. Now, the first 2 weeks we really focused on the principles, the foundation. If you're going to be able to explore, the use of embryos and some of the other ethical things that may endanger life and so forth, and pit those against those things that may protect or preserve life, it was very important that we spent a lot of time in those early weeks. Today's lesson actually is going to go fairly quick. In comparison. But I want you to still put in the time for today's lesson. And as you put in that time, next week's going to be a light lesson. When we get into eugenics, we're going to be spending a lot of time. So it's going to balance out in the long run. Now, on stem cell research, we're going to focus on just understanding what it is. We'll start by looking at what it really is, how it works. I want to begin by asking the question, why the interest? We sometimes want to get right into explaining the details of stem cell research, but why is there interest? Before we talk about embryos and blastocysts, I think it's important to understand the passion that's driving this topic. Now, this quote is from James Ramstad. He was a former moderate Republican from Minnesota who served in the House of Representatives, and I think it sums up the dream of stem cell research. He said, "Embryonic stem cell research will prolong life, improve life, and give hope for life to millions of people." When you have a promise like that, it makes it difficult to have a professional objectivity that is critical to making sound ethical judgments. People who would talk about this kind of passion, who talk with this kind of passion for stem cell research, and particularly embryonic stem cell research, clearly do not are not walking into it objectively. There's a lot of good things we could do by getting rid of people. There's a lot of good things that we think we can do by doing some radical experimentation, and we find those things objectionable. And yet, when we get down into the stem cell level, working with embryonic stem cells seems to be more of a throwaway. We've had some otherwise pro-life legislators come out in example of embryonic stem cell research. A good example is Orrin Hatch from Utah. Senator Hatch, who had been just a darling of the pro-life community, very much jumped onto the embryonic stem cell bandwagon, and as a result has been pretty much ostracized by the pro-life community. When research is promoted with such lofty promises of success and healing, opposition is degraded with sarcasm, and the will of God is replaced with the notions of God's will, as we see in this quote from Representative Chris Shays. He's also a moderate from Connecticut. He said, "I think it's time we recognized the dark ages are over. Galileo and Copernicus have been proven right. The world is in fact round. The earth does not revolve around the sun. I believe God gave us intellect to differentiate between imprisoning dogma and sound ethical science, which is what we must do here today." Now, while opposition to some forms of stem cell research has nothing to do with the Dark Ages, opposition to Galileo or Copernicus, or though no one is tying opposition to a notion that the world is not round or that the earth does not revolve around the sun, critics of opposing views are quick to speak foolishly rather than wrestle with the issues at hand. They don't want to talk about whether embryonic life is life. They want to talk about all the good it can be done. And then if you hold to some sort of sound principle, immutable principle, you are characterized kind of as being unintellectual, being superstitious, or being foolish. In a graphic made available by the National Institute of Health for educational purposes, there are 4 primary areas of promise for stem cell research. 1, it helps us understand how to prevent and treat birth defects. 2, through cell differentiation, to generate tissues and cells for transplantation. And personally, I have found the transplantation argument or perspective of this to be perhaps the hardest driving force. Okay, number 3, for testing drugs on human cells and culture. This is primarily for pharmaceutical use. And then they actually have, for number 4, a question mark. Who knows? That's how lofty the expectations are for the success of stem cell research. It suggests that the scientific community is giddy over its possibility because these are considered to be foundational cells upon which human life exists. So they see it as curative, they see it as healing, they see it as life prolonging. So everyone's real excited. So that question mark is there just so that those possibilities are seemingly endless. Susan L. Solomon, and don't confuse her with another Susan Solomon, who is famous as an atmosphere chemist. This Susan L. Solomon is the CEO of the New York Stem Cell Foundation. In her 2012 TED Talk on the, quote, promise of stem cells, end quote, she makes a compelling case for stem cell research. But in the process, you'll notice that she blurs the line between controversial stem cell research, which is the kind dealing with embryos, and all other kinds of stem cell research. The URL I have provided is a hyperlink to her TED Talk. Take 15 minutes and watch her talk. See if you sense any feel for what is the real controversy, and observe how the hype and the promise is overwhelming in her presentation. She's a rather dry presenter, but you just see this giddiness about her, excited about the potential. And we should also share in that excitement. There is a lot of good to be gotten from stem cell research. We have to deal with that controversial element, the destruction of embryos. Okay, let's get into the details. So we're clear in what we're talking about with this umbrella term called stem cell research. One thing you'll notice is when you read about stem cell research discoveries and research in the newspaper, they rarely differentiate between whether this is adult stem cells, induced pluripotent stem cells, or embryonic stem cells. They'll just have this broad umbrella of stem cells. And oftentimes I find that the media, either one, doesn't understand the distinction, two, they think that the distinction is foolish and so won't give it credibility by making the distinction, or three, are really intentionally trying to blur it, which is very similar to number 2, I guess. Okay, when I did a Google search for, quote, what is a stem cell, it gave me a very simple answer. An undifferentiated cell of a multicellular organism that is capable of giving rise to indefinitely more cells of the same type, and from which certain other kinds of cells arise by differentiation. Now, if you don't like the word undifferentiated, many definitions just call them blank cells. These really are kind of like foundational cells that can be triggered. Now, I have a personal theory that, we're always limited by technology for the day. So I wonder if 100 years from now, the stem cell will actually be seen as foundational as it is. There's still a lot of questions about what triggers stem cell development into muscle tissue and nerve tissue and so forth. And so there might be even a more basic level. I find this a lot in discussions about Big Bang Theory, Higgs boson, and so forth, is that they're all excited because we found this foundational particle and so forth. But quite honestly, science and research is always studying, digging deeper, modifying, and so forth. But either way, this is the working definition for stem cell. When I visited the National Institute of Health website on stem cell research, its definition of a stem cell sounds more like a commercial than a definition, but from it you can glean the essence of what a stem cell is. The definition reads, stem cells have the remarkable potential. Okay, already remarkable is hardly a defining word. It's an adjective, a remarkable potential to develop into many different cell types in the body during early life and growth. In addition, in many tissues, they serve as a sort of internal repair system, dividing essentially without limit to replenish other cells as long as the person or animal is still alive. When a stem cell divides, each new cell has the potential either to remain a stem cell or become another type of cell with a more specialized function, such as a muscle cell, a red blood cell, or a brain cell. Stem cells are distinguished from other cell types by two important characteristics. First, they are unspecialized cells capable of renewing themselves through cell division, sometimes after long periods of inactivity. Second, under certain physiologic or experimental conditions, they can be induced to become tissue or organ-specific cells with special functions. In some organs, such as the gut and bone marrow, stem cells regularly divide to repair and replace worn out or damaged tissues. In other organs, however, such as the pancreas and the heart, stem cells only divide under special conditions. And it's interesting because there's been some fascinating experiments done with heart repair being done with stem cells. And we'll get into that later, and you'll see that in some of your research. In a discussion about stem cells, they are essentially divided up either by their source or by what they can do. Right now, we're going to focus on what they can do. And so when you talk about what stem cells can do, they're divided into three areas: totipotent, pluripotent, and multipotent. Now, sometimes multipotent is called unipotent and so forth, but generally totipotent, pluripotent, and multipotent are the three standard definitions for understanding what stem cells can do. Totipotent. A totipotent stem cell is considered the most versatile of all stem cells. At the moment of fertilization, a fertilized egg is considered a totipotent stem cell, which means it has the potential to become the totality of all human cells, and that includes cells outside of the body, and then such as the placenta, the cells that form the placenta. As near as we can tell, at this stage there is absolutely no differentiation. After about 4 days, a totipotent stem cell begins to turn into a pluripotent stem cells through cell division. Now we get into pluripotent stem cells. Pluripotent stem cells are very similar to totipotent stem cells, except pluripotent stem cells are still considered undifferentiated cells that can develop into any cells within the body. Pluripotent cells do not form placenta. So while totipotent cells become a new organism, with the internal cells and then the external cells, the placenta and so forth, pluripotent cells become the internal organs and the internal tissue, and is not a completely new organism. In this diagram from Wikipedia, pluripotent cells would be the developing cell mass within the blastocyst stage of embryo development. We talked about some of these stages in the last lesson. Those inner mass cells are the ones most spoken about in promoting the benefits of stem cell research. These are the ones that, in order to harvest them, the blastocyst has to be pulled open, and those pluripotent stem cells are harvested, and therefore that developing life that had started at fertilization, went through the morula stage, gets ended at the blastocyst stage before it moves on into embryonic stage and then goes into embedment into the uterine wall. So you can see why pluripotent cells are controversial, because it stops the developing life. Okay, using that same Wikipedia graphic, Multipotent stem cells are sometimes called unipotent stem cells. Don't be too concerned about the two terms. Really, quite honestly, this is the first time I had seen unipotent used. I think I saw it referenced in one other paper, I guess, but almost everyone's calling them multipotent cells, stem cells. And these are ones where differentiation of the stem cells has begun to occur. It's past the pluripotency stage. Generally speaking, multipotent stem cells differentiate into specific groups of cells, and within each of those groups some differentiation still occurs, but it becomes more restricted. For example, if it differentiates into blood cells, then the blood cells might further differentiate, or the blood cells will further differentiate into different kinds of blood cells, but they will not become muscle stem cells. So in other words, once they have this initial differentiation, they will only further differentiate within that family of cells. Now perhaps the most widely known multipotent stem cell work that's being done today has been done for many years. Those of us who are older used to just call it bone marrow transplantation. It essentially is the transplantation, usually of multipotent blood stem cells that's found in the bone marrow. That's done with treating cancer patients. Now, let's look at stem cells not based on their use, but based on their source. The creation of totipotent stem cells is essentially what is going on, first of all, just through normal reproduction, but it's also going on with in vitro fertilization. Now, we have not assigned IVF as a discussion topic in this course on bioethics and biotechnology, but there's a lot to be said because there's a astronomical failure rate in IVF research. There's thousands upon millions, I would guess, by now, of developing life in that small embryonic stage that is either dying because of unfamiliar, unfriendly circumstance, or it's discarded for not being what they want it to be. It becomes frozen and then left later on, and so forth. As to the debate related to stem cells, quite honestly, no one is arguing about totipotent stem cells. So don't worry about when it comes to how they are attained. We can argue about in vitro fertilization on another day. But I will say this, that later on somewhere in this class, I'm going to quickly insert a link to a video clip in which Michael J. Fox was interviewed by Katie Couric. And in that video clip, I guess I used that in the last class. If you recall, in that video clip, he did make the comment about how, well, nobody had trouble with IVF and nobody had trouble with the number of embryos that were disposed of then. We're just finally getting practical use out of it. So totipotent cells, I think, are a concern when they're created man-made and they're destroyed. But for our discussion here on stem cell research, totipotent cells are just basically their source is from reproduction. For our sake, we'll talk about natural reproduction or IVF. Pluripotent stem cells are at the heart of the controversy over stem cell research. The primary source for pluripotent stem cells are developing embryos halted and destroyed at that blastocyst stage. It's usually about 5 days after fertilization has occurred. Now, in order to harvest these pluripotent stem cells, as I said earlier, and they're also called embryonic stem cells, it requires destroying the developing life in order to get to those stem cells. You cannot extract pluripotent stem cells and protect the developing life. But those pluripotent stem cells are removed and they're placed in a growth solution. Now, I provided a URL there to the diagram, but if you look at the top under explanation of the slide, you can check out a brief process that explains how this is done. It's a good visual explanation. If you got a moment, take a look at it. Multipotent stem cells come from two primary sources: existing tissue or organs, which is why they are also called adult stem cells, or umbilical and placenta cord blood, which many feel might be slightly better than adult stem cells in terms of their plasticity. So there's an entire industry that's come out of the whole idea of preserving the placenta. If you deliver a child, there's a collection bank that will harvest basically your placenta that was delivered in the afterbirth, and they will freeze it. And the idea is that as science continues to progress and we find better uses and know how to use stem cells better, that the blood that's frozen, the blood stem cells frozen in the placenta of your child, could possibly used to treat a malady in your child even as an adult, and it presumably would remove rejection issues because it's essentially the child's own placenta. Now be aware of the fact that neither use of placenta blood or adult stem cells are controversial. Generally, they're not controversial. There will always be people who will say, we ought not to be playing God, we ought not to be messing in this area. I don't buy those arguments. I think, anytime you accidentally cut yourself and you put a Band-Aid on it, you are essentially taking a remedial action rather than letting, quote, nature take its course. And this is what God would have us to do. The Apostle Paul advised Timothy to take a little wine for his stomach. I mean, that's taking some remedial efforts. This gets more technical when we start getting into stem cell research. But when we're talking about adult stem cells and placental stem cells, or the blood cells from placenta, this is not controversial. We very much like this kind of research and encourage it. Now, in 2006, Dr. Shinya Yamanaka discovered a technique using mice by which skin cells can be extracted, those are adult cells, treated with chemicals, and essentially reprogram them back to the stem cell, their embryonic stem cell or pluripotency condition. Now, he replicated this with humans in 2007. And this brought him he shared a Nobel Prize for physiology or medicine in 2012 on this. It's an incredible thing. It has revolutionized the industry. It's called iPSC, or induced pluripotent stem cells. The iPSC procedure accomplished two very important things. One, it removed the ethical problems with destroying embryos, as is done in embryonic stem cell research. And two, this process greatly reduces chances for rejection because the skin cells can be extracted from the patient requiring the stem cell therapy. And we don't spend really any time on the whole discussion of rejection, but as I've worked in this bioethical field for the last few decades, I've been amazed over how driven it is by the transplant industry. Now, right now I'm still carrying around that little sticker on my driver's license that says if I'm in an accident and I've died, you can use my organs for transplantation. But the whole organ transplant industry is, not satisfied because they don't get it. They never get the organs early enough. Upon death, if they can't put you onto a machine to keep the organs oxygenated and so forth, they're not any good. So sometimes people who have their sticker on their driver's license for it, and the family has said it was okay. Sometimes they die at home and they don't discover the body until later. Sometimes they die, in a hospital bed or something, and they can't get it. And so there's always been attempts to try to maneuver or to modify the definition of death to harvest organs sooner. Right now, organ donation still, in my opinion, in the United States, is still safe, and it's a good thing. I don't find anything contrary to Scripture in it. But you still always have this problem of rejection. And so with iPSC, that's a big deal. I mean, if we can treat you with your own stem cells, we can greatly reduce or eliminate any rejection that comes from the developing tissue. All right, now, I have a link there for an instructional video. I want you to check that out. It's good for you to have a good understanding of this, because this has got legs, if you know what I mean. This caught on in 2006. It was done successfully in 2007 on adults, on human beings, and it's still out there. They're still doing it. There's been an awful lot of discoveries announced in stem cell research that wasn't replicated and got dismissed, and people have been disgraced, people have been fired, and so forth. Yamanaka's discovery here is valid, and it's working, and I don't know if they're doing any iPSC work at Concordia University. I do know that Professor Rob Balza at Wisconsin Lutheran College is doing iPSC work, and it's fascinating work. He's working on trying to regenerate heart tissue. So very fascinating. Be sure to read that. Now, be advised, there are critics who worry about why it takes too long to extract and to convert skin cells into pluripotent cells, and so they say it's too hard, it's too much work. We have this ready supply of frozen embryos left over from IVF. We can use those. So they'll argue about that. There's been some concern about the fact that if you take, I'm 58 years old. If you take my adult stem cells, my DNA in the skin cell is 58 years old, and so they're worried about, okay, so is there any problem with having an old DNA involved with these converted or regenerated pluripotency stem cells? So those are the kinds of things, some catfighting going on. But iPSC I think, is the area where Christians can find promise without the ethical overtones. Now, for the first two lessons, I provided 3 separate PowerPoint presentations for each, plus I assigned reading. I think it was a lot of work. I gave you a lot to do there. For this lesson, I'm only doing this single PowerPoint presentation. I want you to focus your time on reading the assigned text entitled Sacred Cells. It's written by Ted Peters and others. Let me explain a little bit of something about this reading. When I was asked to teach this class in bioethics and biotechnology, I realized that for the most part, in different areas of bioethics, I could pretty much talk off the cuff. I've done a lot of studying on healthcare and the way it's used. I've done an extensive amount of study on birth control and hormonal effects on the body and so forth. But I had to, I had this little bit of a void in the area of my knowledge on stem cells. Not that I didn't know how it worked. I definitely knew how it worked, and I definitely knew the ethical things. But I'm a firm believer that it's very valuable to learn the history behind it. Because sometimes the circumstance and the setting helps you more clearly understand early concerns, extenuating circumstances, things that it's kind of like, people who quote one Bible passage and they make a bumper sticker out of it, but they take it out of context and it's not clearly understood. And so what I did is, I have a friend of mine that's a futurist. If you go and do a Google search called futurist speaker, I think he's the first one who comes up. His name is Tom Fry. Tom and I have been friends for probably 25 years or longer. And when I got this, I wrote him and I said, Tom, I need to find I need to find more information on this, and as a futurist, he's probably aware of where this is going and everything. And what he did is he put me in touch with a professor out at Regency University out east. And I have another friend at Regency University out there. So I made some connections out there. And this guy said, well, I can help you, but what you really need to do is you need to go to the source guy. This is this Dr. Ted Peters. And Ted Peters taught at a Lutheran University out in the West Coast, I believe out in the Seattle, Washington area. So he gave me Ted's email address. So I emailed him, and he was very helpful. He's just retired recently, and he said, I've written a number of books on this topic. Here they are. Quite honestly, you can find these books used on Amazon. I think I didn't pay any more than $1 or $2 for them. But this book in particular is fascinating because he talks about the very early work that's done at Geron, which is a big company in this industry, that had been done at Geron, and how he had wrestled with the ethical things. Now, I will tell you, I believe we should support stem cell research. I do not believe we should feel comfortable supporting embryonic stem cell research. So you may find times where Ted Peters, I think, fell off the track on occasion. But overall, it's a very easy read, and it's a brilliant explanation, and I think it's a valuable resource for understanding how this all began. All right, now, in a perfect world, I'd love to have you read the whole book, but it's 242 pages. I think that might be a little bit too much, and so you'll see that on the course assignments that I said at a minimum I'm requiring you to read chapters 1 through chapter 7, chapters 10 through chapter 12, and chapter 17 and 18. That makes a total of 160 pages. So you might say to yourself, well, I might as well read the other 80 pages and just go. But at least 2/3 of this book I want you to read, because that's where we're going to have our discussions and so forth. And hopefully we'll have some Skype sessions or something. I can handle questions, and I'll be able to grasp your understanding of the topic and the ethical considerations, particularly in the essay questions on this. So that concludes the PowerPoint presentation on stem cell research. Devote your time to reading. Check out a couple of those links I gave you on how stem cells work, and I think you're going to have a real good understanding of it. We'll look forward to communicating on this in the discussion area.